Assalamualaikum and very good day to my respective panel, Dr. Amir Abdullah and Dr. Zulkarnain. So, in this video presentation, I will present about my PSM project, which is modeling of HVAC air diffuser performance by CFD method. So, let's begin with the contents of my presentation. First is the introduction, and then we will go through the problem statement, objective, and scope of research. Next, we will go through literature review, and then methodology, and lastly, expected and preliminary results. So let's begin with the introduction. So as we can see from the figure shown in the slide, it is an illustration of an air distribution system where the air starts flowing from the air handling unit, flowing through the ducting, and then goes into the diffuser, which is located at different zones. So the air that is supplied by the system, we can call it conditioned air. So every component that we can see in this illustration is the main component of an air distribution system. But for my research or my study for this PSM, I am more focused towards the diffuser itself. So diffuser is one of the main components of an air distribution system. The airflow pattern is dictated by the design of the diffuser. So different design of diffuser produce different type of air projection. And we can say that selection of air diffuser is crucial to provide thermal comfort efficiently to the occupant. Okay, next we will proceed to problem statement. Improper design of an air diffuser reduces the efficiency of an mechanical ventilation system to distribute conditioned air as well as providing thermal comfort. So how do we evaluate the performance of an air diffuser that we design? So one of the best way is by using CFD method, and CFD stands for computational fluid dynamics, and it requires the application of a CFD software. And for my case, I will be using NC software. Next, we will go to the objective. First one is to model a ceiling diffuser using NC's design modeler based on actual design. The actual design that I have just mentioned can be seen in the figure on the right, on the bottom right, which is a plate type ceiling diffuser. So I will be modeling a geometry that resembles the actual device, and the dimension of the model will be according to this actual design. So for the next objective is to conduct a CFD study of the air diffuser performance, and this study will be focusing on temperature distribution and airflow characteristic. For the airflow characteristic, to be more specific, it will be focusing on air velocity profile and the turbulence kinetic energy produced by the diffuser. So we will see how this type of design of diffuser will affect the velocity profile in the room, and also the turbulence that occurs in the room. For the last objective is to study the effect of diffuser location upon the airflow characteristic and temperature distribution. So the parameters are just the same, airflow characteristic and temperature distribution. The only manipulated variable is the location of the diffuser in the room. So for first try, the diffuser will be located in the center of the room, and then I will be changing the location, maybe on the corner of the room, on the side of the room, and then we will see how the location will affect the airflow characteristic and temperature distribution. Okay, next is the scope of research. First one is inlet velocity is in range between 0.2 meter per second and 0.6 meter per second, and this value is taken from previous research paper which also conduct CFD study for diffuser. So I will be using the same value for my research. And the next one is a single room with dimension of 3.6 meter times 3.6 meter times 3 meter. This dimension also is based on previous research paper. So this value will be the same. The only thing that is different is the type of diffuser that I will be modeling. So for the third point is a flat type ceiling diffuser with the dimension of 19 inches times 19 inches. And this diffuser model that I will be using is based on the actual device, just like I have just mentioned earlier in the objective. For the last part is opening of diffuser outlet with the measurement of 1 inch. This value also is taken from the actual device. Okay, next we will go to literature review. For this chapter, I have summarized all the research paper that I have read and translating it into table form, just as shown in the figure or in the slide. On the left side is the field of study representing the focus of the research paper. Middle part is the author, and on the left side is the my findings when I have been reading the research paper. So let's focus on my findings. First one is implementation of K epsilon turbulence model. So this turbulence model is important for my research because it will be applied when running the simulation for the CFD study. Next one is impact of airflow rate towards the temperature and velocity. So the keyword here is the temperature and velocity, and these two things match with my objective, which is to study the airflow characteristic and temperature distribution in a room. And then for the third one is distinction in terms of throw pattern profile of different type of diffuser. So for my case, I will be using only one type of diffuser, which is plate type. And once the simulation is completed, I can compare my results with the previous paper. Next is finding from Ashray handbook. So in this paper, it just gives me general insight on the importance of proper air distribution, which is the fundamental of my PSM project. And then next is effect of diffusers design on temperature, velocity, and air projection in the room. So this paper also quite similar with my project. So I might be using similar method proposed in this paper in my project. And lastly is the visualization of Coanda effect through CFD study. So once the simulation is completed, I might be able to display the Coanda effect and compare it with the previous paper. Okay, let's proceed to methodology. The diagram represent my approach to complete this PSM project. So starting with qualitative research, meaning that the reading of previous research paper regarding CFD study for air diffuser. So my method to complete this project might be based on the methodology proposed by the previous paper. Then for the next step is selection of diffuser design. In this case, I will be referring to an actual design of diffuser and then take the measurement. So the measurement will be implemented in the ANSYS software. And then proceed to modeling of 3D geometry. So by referring to the measurement that has been taken, I will proceed to model the diffuser in the software. So starting from 2D sketches and then translating it into 3D model. So once the modeling has been completed, we will proceed to the simulation of the computational domain. So the computational domain, it will be representing the room. So the room, just like I have mentioned before, with the dimension of 3.6 meter times 3.6 meter and 3 meter. And then once the simulation has been completed, for the result will be the visualization of airflow characteristics and temperature gradient. So this figure shown in the slide represents the methodology that I have just proposed earlier. So this is the selection of diffuser, the plate type sealing diffuser, and then the measurement process of the diffuser. Okay, from the left side is the 3D geometry of the diffuser. This model has been generated using the ANSYS design modeler. And then moving on to the next figure is the computational domain representing the room. So by creating this computational domain, it ensures that the air only flow from the diffuser and into the domain itself. And next figure shows the simulation of the computational domain. So in this simulation, few steps has been taken to run the calculation. For example, the implementation of K epsilon turbulence model, and then the inlet temperature, which is 287 Kelvin, and then the velocity of the inlet, which is 0.6 meter per second. So the result of the calculation can be seen on the last figure. So it shows the turbulence dissipation in the room. Okay, for this slide, it is the expected results from this simulation. So the simulation should be displaying the velocity profile just as shown in the figure, and also the temperature gradient. So for the last part is the preliminary results, and I have conducted the simulation to evaluate whether my geometry modeling is correct and my settings for the simulation is correct. So first figure on the left, it shows the meshing of my computational domain. Doesn't seem to have any problem during the meshing process. But once I have proceed to the calculation, there seems to be problem with the velocity profile. And as we can see from the second figure, the air velocity doesn't seem to be properly distributed around the room. So there might be some problems with my geometry. So in order to provide a better result, I might need to alter the geometry and then revise my selection of meshing method and also revise the boundaries condition that is set during the simulation process. So for the third figure is the turbulence kinetic energy. Seems don't have any problem. And for the last figure is the temperature gradient in the domain. So since the velocity only focusing on the center of the room, the temperature gradient also shows the same characteristics. So just the same, might need to be the geometry might need to be altered to provide better results. So this is the suggestion for improvement to my simulation results. For modeling, I need to make alteration of the geometry that is disrupting the process of meshing. So if there are any disruption on the meshing process, it might affect my results in the simulation. So for example, my domain might not be able to display a proper air distribution and temperature gradient. And then for meshing, I need to revise my selection of meshing method, either using tetrahedron or cut cell. So this is to ensure the software is able to perform calculation that covers the whole geometry. And for the simulation part, I need to make sure that every parameters are set or are defined accordingly so that I will get a accurate result. So for the parameters, the inlet velocity is just like I have mentioned before, in range between 0.2 meter per second and 0.6 meter per second, and the inlet temperature should be at least 287 Kelvin. So we have reached the end of my presentation. So thank you for your attention.